We'll now return to dictionaries, which lie at the heart of many Python programs, including the Python interpreter itself. We briefly looked at literal dictionaries previously, seeing how they are delimited with curly braces and contain comma-separated key-value pairs, with each pair tied together by a colon. The values are accessible via the keys. The keys must be unique within any single dictionary, although it's fine to have duplicate values, so long as they're associated with different keys. Internally, the dictionary maintains pairs of references to the key objects and the value objects. The key objects must be immutable, so strings, numbers, and tuples are fine, but lists are not. The value objects can be mutable, and in practice often are. Our example URL map uses strings for both keys and values, which is fine. You should never rely on the order of items in the dictionary. It's essentially random, and may even vary between different runs of the same program. As for the other collections, there's also a named constructor, dict, which can convert other types to dictionaries. We can use the constructor to copy from an iterable series of key-value pairs stored in tuples, like this. Recall that the items in a dictionary are not stored in any particular order. So long as the keys are legitimate Python identifiers, it's even possible to create a dictionary directly from keyword arguments passed to dict. As with lists, dictionary copying is shallow by default, copying only the references to the key and value objects, not the objects themselves. There are two means of copying a dictionary, of which we most commonly see the second. The first technique is to use the copy method. Here we copy a dictionary of color codes. Note that we supply them in hexadecimal, but they're echoed back to us in decimal. The second means of copying is simply to pass an existing dictionary to the dict constructor. If you need to extend a dictionary with definitions from another dictionary, you can use the update method. This is called on the dictionary to be updated and passed the contents of the dictionary which is to be merged in. Here we merge in some additional color codes into our existing dictionary. If the argument to update includes keys which are already present in the target dictionary, the values associated with these keys are replaced in the target by the corresponding values from the source. As we have seen in an earlier module, dictionaries are iterable, so can be used with for loops. The dictionary yields the next key on each iteration, and we retrieve the corresponding value by lookup using the square brackets operator. Notice that the keys are returned in an arbitrary order, which is neither the order in which they were specified, nor any other meaningful sort order. If we want to iterate over only the values, we can use the values dictionary method. This returns an object which provides an iterable view onto the dictionary values without causing the values to be copied. There is no efficient or convenient way to retrieve the corresponding key from a value, so we only print the values here in this example. In the interest of symmetry, there's also a keys method which provides a view onto the keys of the dictionary, although it's not often used because default iteration of dictionaries is by key. Often, though, we want to iterate over the keys and values in tandem. Each key-value pair in a dictionary is called an item, and we can get hold of an iterable view of the items using the items dictionary method. When iterated over, the items view yields each key-value pair as a tuple. By using tuple unpacking in the for statement, we can get both the key and value in one operation without the extra lookup. The membership test for dictionaries use the in and not in operators and work only on the keys. Here we create a dictionary mapping ISO currency codes to Unicode currency symbols. We use the membership testing operators to show that the New Zealand dollar is in the list of symbols, whereas the Macedonian dinar is not in the list of symbols. Here we use the del keyword to remove the fictional element unobtainium from our periodic table. The keys in a dictionary should be immutable, although the values can be modified. Here's a dictionary which maps the element symbol to a list of mass numbers for different isotopes of that element. See how we split the dictionary literal over multiple lines. That's allowed because the curly braces for the dictionary literal are open at the point of the line break. Our string keys are immutable, which is a good thing for the correct functioning of the dictionary, but there's no problem with modifying the dictionary values in the event that we discover some new isotopes. Here the augmented assignment operator is applied to the list object accessed through the H for hydrogen key. The dictionary is not being modified at all here, but the list is being extended. Of course, the dictionary itself is mutable. We know we can add new items. Here we add 3 isotopes of nitrogen. With compound data structure such as our table of isotopes, it can be helpful to have them printed out in a much more readable form. We can do this with the Python standard library pretty printing module called pprint, which contains a function called pprint. To use it, it's best to do something like from pprint import pprint as pp. If we didn't bind the pprint function to a different name, pp, the function reference would overwrite the module reference, preventing further access to the contents of the module. Arguably, it's poor design to have a module containing functions of the same name because of this issue. Anyway, by using ppm, we get a much more comprehensible display of our table of isotopes. Let's move on from dictionaries and look at a new built-in data structure we have not yet met, the set.